In terms of the nomenclature, it's pretty simple. The ending gets amine. So for example, if you had cyclohexyl amine, right? The cyclohexyl part tells you that you have a cyclohexane, and then the amine part tells you that you have an amine. In this case, just a primary amine. Remember, the benzene version gets a special name, that's aniline. And then, of course, we can have other compounds with amines. If there's other functional groups that take priority of the amines, instead of ending with an amine, it'll start with an amino. So for example, 2-amino butanoic acid, right? The butanoic acid part, 4 carbons long, carboxylic acid. And then on the second carbon, 1, 2, we have an amine. So there's our 2-amino butanoic acid. We can have multiple R groups, and you can name them kind of however you want. So for example, like triethylamine is, as the name implies, an amine, and then it's got 3 ethyl groups on them. You can name them something like ethyl methyl amine. Again, very self-explanatory. There's an ethyl, there's a methyl, and then nitrogen has 3 bonds, so there's obviously a hydrogen as well. Or if you want to use another form of nomenclature, you could use N to indicate that the stuff is coming off the nitrogens. So N dimethyl propyl amine, right? Propylamine, 3 carbons, and then a nitrogen. So there's 1, 2, 3 nitrogen, and then on the nitrogen, there's 2 methyl groups. 1, 1. Another fancy one is pyridine. It gets a special name, and so that's kind of like our benzene ring, except the nitrogen is now part of the benzene ring. And then remember that the lone pairs of this pyridine, they do not participate in resonance. So just write does not resonate with ring. It's in an sp2 orbital, and it cannot hybridize to an sp orbital because then the bond angles would go crazy. And that's a review kind of from our aromatic chapter / electron delocalization chapter.